Today I would like to talk about 2012 AMC 10A Problem 15. 3 unit squares and 2 line segments connecting 2 pairs of vertices are shown. What is the area of triangle ABC? So we're going to try a different approach. We're going to add a coordinate plane. We're going to add a coordinate plane to this graph, with the origin being this point here. So that is the y-axis, and that is the x-axis. Now we already have some coordinates because it says it's 3 unit squares. So this point here is 1, 1. This point here is 2, 1. This is the origin, so it's 0, 0. This has a height of 2, so it's 0, 2. And point B here has a height of 2 and the x-coordinate of 1, so it is 1, 2. So why do we need these points, and why are we actually adding the coordinate plane? Because it looks like a geometry problem more than a coordinate plane problem, right? So firstly, you want to figure out the area of ABC. That's our goal, that's literally our goal. And to figure out the area of ABC, we have base times height. We have base times height to do it. So you can either figure out AB and also this line here, this altitude here on the side AB, or we can prove that ACB is a right angle, which looks possible, and then find out BC and AC. So we'll go with the first approach, which is finding AB, which we already have. AB is just 1, and also finding the altitude. So we know that AB is 1 because the x-coordinate of B is 1, and the x-coordinate of A is 0. So AB is already 1. So now we just need the altitude part. So how do we find the altitude? Well, basically, firstly, we take a look at these 2 lines here. The origin to B and A to this point 2, 1. So what's special about these 2 lines? I'll call this one L1 and I'll call the second one L2. For L1, the line intersects at 0, 0 and 1, 2. So we can calculate the slope. We can calculate the formula for L1. So it's y equals mx because the line intersects at the origin, and we plug 1, 2 in, then we get 2 equals 2 equals m. So m is 2. So the equation for L1 is y equals 2x. Now the equation of L2, we can also calculate it using the same thing. We have y equals mx plus 2 because the y-intercept here is 2. If we plug the values in for 2, 1, because it intersects at 2, 1, then we get 1 equals 2m plus 2, or basically m equals negative 1/2. Therefore, L2 would be y equals negative 1/2 x plus 2. So these are our 2 lines. So as we're going to go with the first approach, the slopes don't exactly matter. But if we're going to go with the second approach, then we can see that the slopes are negative reciprocals of each other. So this angle is indeed 90 degrees. But now we're going to go with the first approach. So basically, what is this altitude? Well, to figure out the altitude, we have to subtract the y-coordinate of point C from the y-coordinate of this point. We know the y-coordinate of this point because it's on AB. AB is parallel to the x-axis, and point A and point B all have a y-coordinate of 2. So this point has a y-coordinate of 2. We just need point C. But luckily, point C is the intersection of L1 and L2. So we just do some algebra. So if we plug 2x into L2's equation, then we get 5 over 2x equals 2, which is basically x being 4 over 5. So the x coordinate is 4 over 5. And we know that y equals 2x, so we have x is 4 over 5. And also y is 2x, which is 8 over 5. So now we have the x and y coordinate of point C. We can subtract, we can minus 8 over 5 from 2 to get the distance from C to AB. And 2 minus 8 over 5 is 10 over 5 minus 8 over 5, which is 2 over 5. So the altitude from C to AB is 2 over 5. So now we have the altitude and base. The area is just 1/2 times 1 times 2 over 5. So this is the area. If we cancel out this, we have the area to be 1 over 5. So the area, or our answer, is 1 over 5. And this is answer choice B, so we circle that. So thanks for watching. I hope you liked the video and you learned something useful about how to use coordinate planes when you face problems with unit squares or any units. So thanks, bye.